Now we want to explain the question 5. For the first step, we must draw a free body diagram. The friction must opposite to the force, and the weight must go downward 90 degrees to the surface, and the normal force must be opposite to the weight. For the second step, we must find acceleration, so we use the kinematic formula. Kinematic formula have three different. But we use only for one formula, V equal to V naught AC times T. V at the question, it said the velocity is 10 meter over second, and V naught is start from at rest, so the V naught is 0. The acceleration, we want to find it, and the time is 5 seconds. So ASC is equal to 10 over 5. So the ASC is equal to 2 meter over second square. So next step, for the third step, we use equation of motion. For equation of motion, we have to resolve it into two directions, x-axis and y-axis. The summation at x-axis is equal to MA. So at x-axis we have P cos 60 degree minus friction equal to MA. To find a friction, we have friction is equal to N times mu K equal to MA. To find the N, we must to make a summation at y-axis. Summation at y-axis is equal to MA. At y-axis we have normal force minus weight plus P sin 60 is equal to 0, because at y-axis we don't have acceleration. That's why it will be 0. For the NC, we don't know. For the weight, 90 times 9 plus P sine 60 is equal to 0. And C is equal to 50 times 9181 is equal to 490.5 plus minus P sine 60. So this is the equation number 1 and this equation number 2. Step number 4. Equation number 1, P cos 16 minus N, we take from the equation number 2, 490.5 minus P sine 16 times mu k. Mu k we take from a equation 0.2 equal to mass 50 times the acceleration we get at the second step, 2. So we will find the P. The P is 294.35 Newton. So this is the answer for the equation A. For equation B, it asks us to find the normal reaction. To find the normal reaction, we must put the P at the equation number 2. So NC is equal to 490.5 minus P 294.35 sine 60. The NC is equal to 235.59 Newton. So that's the answer for the equation B. That's all.
So for question number 6, we have 3 situations to prove that the man's angular velocity. For the first situation is when he holds the wheel upright at theta equals to 0 degree. So we have to know H is angular momentum, I is inertia, and Z is the axis of the man. For first situation, theta equals to 0 degree, we have to use conservation of linear momentum. So we need to sum of HZ1 equals to summation of HZ2. Summation HZ1 equals to inertia axis of the man for omega 1 plus inertia of wheel omega 1 and then summation angular momentum of axis number 2 same, but for this one is omega 2, also the wheel omega 2. The inertia when omega 1 is z of the man omega 2 plus inertia of the wheel omega 2. So omega 2 is equal to I omega minus I omega over inertia of the axis. So the answer is omega 2 of the man is equal to 0. Correction, this one is I will minus I will over Iz. So the answer is 0. For the next one, second situation is when he holds the wheel out at theta equals to 90 degrees. So summation h z 1 equals to summation h z 2. Summation h z 1 equals to Im omega 1 plus I same goes to the second one, Im omega 2. So this one is 0 plus I will omega 1 equals to Im omega m plus I will omega 2. So omega m equals to I omega over Im. I will omega 2 subtract by I will omega 1 equals to I will omega, and then we put omega m as a subject while Im we put below. So for the next situation, as in last situation, when he holds the wheel downward at theta equals to 180 degrees. First, as usual, summation hz 1 equals to summation hz 2. Summation hz1 equals to Iz omega 1 plus I will omega 1. Same as number 2, omega hz2 is to Iz omega z minus I will omega 2. So omega z is equal to I will omega plus I will omega divide by Iz. So we plus the 2i will be 2i over Iz omega.